Hi everyone. In today's video, we're going to talk about generics within Java. Generics were added in Java 5 or JDK 1.5, and they are a really popular tool that is sometimes a little difficult to understand. So what I want to do today is kind of give an introduction to what generics are, how you create your own generic class, and explain a little bit about some of the gotchas when you're using generics without going too deep into them. I'm going to talk briefly about things like type erasure and talk about some of the different things that you want to consider when you incorporate generics into your own code. The main use case that everyone thinks of when they think of generics are for the collections framework. And I got to say, once the language designers added generics into JDK 5, it really made the collections framework that more powerful. Let's get to it, open up IntelliJ, and let's write some code. Today's project, we're going to go ahead and call generics demo. I'll go ahead and start here by what we normally do, and I'm going to create a new class. And I'm going to go ahead and call this generics demo. And now if this class were like any other class, we would create an instance of it. And then we would call some methods on it, or we'd do something with data members within the class. This time we're going to do something a little different. If you recall from the video we did on collections, you can add this thing called a type argument into a certain type of collection class, or really what those are classes that have a type argument field. So how do I use generics in order to make my own classes that require these type arguments? Well, to start, all you have to do within your class declaration here is you add these angle brackets, and then now you give the name of your type argument. I'm going to start by calling it T. All right, so what this did is this just added a type argument. And if I go back to my main and I hover over this, then it's going to give me a similar error it does if I were to create a list, for example, and not specify a type argument. It's telling me that I have a raw use of parameterized class generics demo. And I'll give a refresher on what raw parameterization is referring to. But the gist of it is this code does compile, but it is unsafe and I would not recommend using it. Instead, what you want to do is you want to define the type argument. And in this case, I'll go ahead, I'll call it integer for now. And now what's going on is I have a generic class that in this case is making a generic from integer, but it doesn't do anything. So now I want to demonstrate actually doing something with my class. Let's go ahead first and let's make a constructor. Generics demo. So normally when we make the constructor, now we would add code here. And what I'm going to do differently this time is I'm going to take in a parameter to this constructor, and it's going to have the same type as the type argument right here. And we're going to call it T, and we'll call it data. And now what I want to do is I want to have a field that holds the value of my data within this class. So the type of this field is also type T. And I'm going to call it data. And then now what I can do is I can do this.data equals data. Now, just like we would any other time, instead of calling this an object, a string, an int, whatever you want it to be here, you're calling it T. So this is telling me that I have one related problem. If I click on it and I hover over this, it's saying it's expecting an argument but found 0. The reason for that is because I passed in a parameter into the constructor here. So now I need to give it T. And I might be thinking, okay, so what's T? Well, think about when we have generics demo T. So we have the T within the angle brackets. What do we have in the angle brackets over here? Well, the first problem is we don't even have angle brackets here. So I'm going to go ahead and fix that. Now I see integer here. So I'm going to go ahead and add an integer. And now the code looks good. Watch when I add a string. Now I get an error. If I hover over this, I can't have a string that conforms to the integer inference variable t, and it has incompatible bounds. Okay, so that's a good little bit of information. I'll talk about what bounds are within a generic here later in the video. But the gist is, this is saying this is an integer. So I need to pass in an integer. And now the code looks good again. So one thing I want to talk about briefly is these type arguments. There's a bit of a debate among the community as far as a good naming convention for these. Sun, who was the originator of Java when it first was written, and then Oracle now, who is the current owner of Java, they actually recommend single capital letter type arguments. And the reason they do that is because they say if you have a type argument that looks like a class name, it's going to be hard to read code because you're going to think a type argument is actually a class name when in fact it's just a type argument. The other side of that argument is you have people who want to make this more descriptive. So they might say, I'm going to go ahead and rename this to type arg. So now if I read that code, I can see their point, especially because tools like an IntelliJ highlight type arguments differently, so you can kind of see what they're going after here. But in the end, what you want to do is you want to follow the code conventions of whatever code you're working on. And if you're writing your own code, then you make a convention that makes sense for you. And if people look at your code and complain to you, then maybe you change it, maybe you don't. But point being is that within the community, there's a little bit of debate as far as the best way to name type arguments within generics. So now that we have a constructor and we have this data field here, I'm going to make a getter for my data field. So I'm going to say get data, and it's not going to have any parameters, and it's going to return this.data, and this.data is a type arg. So therefore, the return type of get data has to be type arg. If I go in here, and now I print out demo.getData and run this code. And as we expect, we get the value 1 right here. And I'll change this up really quick. I'm gonna make a string now. And I am going to use string 1 in this case and show that this works as well. Great, and now that's an example of using string as well. Now I want to give an example of why it is unsafe to not include type arguments when you're dealing with generic types. So if I remove this, I know that I'm dealing with strings right now, so this will work. So that works. But now, if I change this to 10, you'll notice that I have this warning right here. Raw use of parameterized class. And it also says unchecked assignment, unchecked call. Those are all basically big warnings saying, hey, as the compiler, I can't go in and check to make sure that your type argument agrees with the type that you're trying to pass in. And when it doesn't agree, like it does in this case, you can get what's called a class cast exception during runtime, which is a lot harder to debug rather than a compile time issue. So in this case, we have a problem because we couldn't detect something at compile time, and then we had to find it at runtime. The whole point of a strong type language is to be able to catch as much as you can at compile time, because finding issues at runtime often gets a lot harder to debug. And in this case, if we just use the tools of the language, in this case, since we're using type inferencing, because we've already defined the type argument within our variable name here, we don't have to define it twice. All we had to do is add these 2 characters, and now the compiler knows that we're not dealing with a raw type, and it gives us this error. So all I need to do is make that a string, and I run the code again, and it works. Great. All right, now the next really important thing to understand about generics is because of how they are implemented and because of the relationship between the type argument and the class that is using the type argument, the type arguments don't follow some of the rules you might be used to when you think of inheritance and polymorphism. And what I mean by that is, let's say that I switch this back to integer. I change this to a value of 10. If I were to look at the integer class from java.lang, you'll see here that the integer class extends the number class. Therefore, if we did what we normally do with inheritance and polymorphism, You could have a number, and then you could have the actual value of the number point to a integer object reference. But when we're talking about generics, it's not that straightforward. So to demonstrate, I can make a generics demo over number. Demo number, I'm gonna call this demo integer. So I can declare the type, but you would normally think you could do this. Turns out you can't. It says that I need to change it over to integer. Okay, that's not a very useful error. You would think because I am assigning demo integer, which is an object reference to a generic object who is using integers as the type argument, that I could assign it to another generic object who's using number as the type argument, but you can't do that. Similarly, if I were to extend this all the way up to object, this doesn't work either. You're pretty used to being able to put object in whenever you want to be a kind of catch-all for any sort of object reference. But the problem here is that generics don't treat the type argument as directly the object reference that you're referring to. It is a qualifier within your class, not the class type itself. So what this means is that you can't use syntax like this. Instead, you have to do something that looks a little funny, and that is you can add a question mark. And what the question mark means is you have an unknown type. You don't even know if it's object necessarily. You just know that it is an unknown type. And if I were to do demo number.getData, if I run this, you will see that it does work as expected. And the reason for all of this is because when you are looking at the type argument here, the type argument isn't actually used at runtime. It is simply a qualifier within the class, and this goes into what's called type erasure. And I'll demonstrate type erasure here in a little bit, but the gist of it is, you might normally think that you can use inheritance and polymorphism with type arguments, but you can't directly when you have instantiated a generic type. You can use it in the context of bounding a type argument, but that's not the same as having a type argument's type use inheritance type characteristics with the generic object that you are creating. Okay, so now I want to demonstrate type erasure. So the way I'm going to do that is I'm going to create a demo integer and a demo number, and they're going to be the same object type with a different type argument. And I am going to compare their runtime class types. And if I weren't using type erasure, they would be different. And if they were using type erasure, then they would be the same. So I'm going to go ahead and prove it here with code that what's happening under the hood in Java is type erasure. So I'm going to go ahead and call this number, new generics demo. I will give this a value of 5 because 5 can be interpreted as a number. And what you can do to get a reference to the type of class that your current object is you can do demo integer.getClass. And I'm just going to do demo number.getClass. And if I hover over this, the IDE is actually already telling me this is always true. So thanks IntelliJ for spoiling the surprise. Type erasure is true. Type erasure is a lie. If I run this, just to make sure IntelliJ isn't going off the rails here. And as expected, IntelliJ is not lying. Type erasure is a real thing. The runtime class type of both the integer generic as well as the number generic are exactly the same. So I've been talking about type erasure a little bit. Let me demonstrate a little bit what I mean by that. When I write the code above, what's happening is I'm doing a lot of compile time checks. So if I were to change this to something that were now not an integer, this is a compile time check, and it'll tell me I'm not going to compile this code because you are using a type argument here that isn't the type argument I defined over here. So if I change that back, now it looks good. After it's done its checks, code will look something like this. I should also print out demo integer get data. All right. So when we actually run the code, what it's going to do instead of this is it's going to get rid of the type arguments. So now it's going to have raw types. Funny, right? And then it's going to instead cast this right here. And if I comment that out and I run this code, I do get the same result. So really what generics get you are a lot of compile time and kind of programmer sanity check safety sort of things. But in the end, what happens is by the time that your code is actually run, it's technically running on the raw types that were available prior to Java 5. And what it's doing is the compiler is generating code that is always going to be safe. And if you don't trust the compiler, then maybe you should trust the compiler a little more, because the compiler is generally going to be pretty good about that sort of thing. It's going to be better than a programmer. And what this allows for is the backward compatibility of code, because the old pre-Java 5 code is going to look just like this. The generics code is going to look like this. And they get compiled into relatively equivalent bytecode by the time that the compiler's done. So that was the overarching concept that the Java designers were trying to get toward when they added the generics framework later after the initial language specification. Okay, so one last thing I want to talk about in this video is I want to talk about bounding our generic types. And the way you do that is actually a little interesting. You use the extends keyword like you would when you're extending a superclass or when you're an interface extending another interface. And in this case, I'm going to make sure that my class can only have type arguments that extend number. So this code is still legal because my type argument of integer extends number. Likewise, this code is still legal, but this code is not. And if I hover over this, type parameter string is not within its bound, should extend number. So why would you want to do this? There are a few reasons. Let's say that your type argument you wanted to guarantee had some certain properties. Well, now you can make sure that any sort of instantiation of your generic object, the type argument has to have those properties because it has a common class or interface that everyone would extend or implement. It also allows more logic that you can add within your class, because now if I do data dot, you can see I've got a lot more in here than what I would normally have just from the object class. If I delete this and I remove here, if I try it again, data dot, I'm back to only what's within the object class. So similar to how all classes inherently extend object, all type arguments inherently extend object as well. And that's an introduction to generics within Java. Hopefully this video was helpful in understanding generics. In future videos, I could go into some more specifics on how you would use generics and how you would want to use them for code extendability while also locking down things that you don't want changed. One other thing that I do get a lot of questions on is what's the difference between generics in Java and templates in C++? And to give you a really quick answer, they are vastly different. They may look pretty similar on the surface, but they are very different in principle and as far as what they support. And I probably should make a video on that in the future. Stay tuned and I'll see if I can do that later on. If you like this video, please do give it a big thumbs up. I'd really appreciate it. Thank you again for watching this video. I hope you have a good rest of your day, and I hope to see you next time. Take care.